just me. I do cancer research or do cancer diagnosis using the AI platform. So without further ado, I'll just share my screen and let's just go straight to what we have or to the business of the day. Okay. So the question and answer is that you can ask the questions after the whole thing. Then the way I section is that before we end, we're just going to have a short or brief practical class, just to have an idea and to introduce you to cancer with cancer diagnosis or machine learning, deep learning using with cancer diagnosis as a use case. Okay, so I will just go straight to my slide. Okay. Yeah. So just like I said, machine learning in cancer diagnosis. Sorry for that mistake in that first slide. Okay, so the outline, the learning outcome, what we're going to learn today, introduction to cancer diagnosis, types of machine learning, the machine learning for cancer diagnosis. We are using that cancer as a use case here. So practical steps involved in machine learning, the data types we have, handling data, materials needed for cancer diagnosis, practice notebook, references, and questions and answers. Oops, sorry, I think this is a mistake. This is supposed to be medical imaging, so kindly ignore that. Okay, so what is machine learning? Well, if you want to look at it, what's machine learning? Machine learning is just a common tool that is, it makes use of algorithm, to detect, to identify patterns, to look at the links within complicated cases, and to accurately forecast the future results of a particular cancer type. How can we call it? We are using it to differentiate whether somebody has a disease or somebody do not have a disease. That's just machine learning. You are categorizing, that is, it categorizes, not just categorizes. You can use it to predict, you can use it to recommend. So there's so many applications of machine learning, But I'm just talking about the layman idea that just to say, okay, to identify pattern, when you look at the data, to identify pattern in the data and see whether a person have a disease or not. Okay, so given the importance of personalized treatment and developing training in the use of machine learning approaches, we offer a review of cancer prediction and prognosis research using this method. Okay, so looking at it now, I'm going to be cutting some little detail because I know that we don't have much time, because reading might not be important. Is when you get to, when we start the practicals, that's when you know that, yes, you're really doing something. Okay, so looking at it, so the machine learning consists of two phases. We have the estimation of unknown. That is, you don't know what the unknown is going to be. And we have one that already have known. That is, we know the categorizing, whether somebody like taking cancer diagnosis. I'm going to focus on cancer diagnosis. Taking cancer diagnosis for, you can say, okay, for instance, say somebody has a cancer or somebody does not have a cancer. That is cancer. Yes, that's cancer is equal to 1. No cancer equals to 0. But there are some cases that we don't even have an idea of whether that person has a cancer or not. That is, we are just going to use our general deductive knowledge to get whether somebody has a cancer or not. Sometimes we call it clustering. That is, we cluster them together. We divide them into types, into different types. So we cluster them together. Okay, maybe sometimes we use this risk score. We can use different types. We can use the risk score. We can use the texture. We can use what we see. We can use different. We can even use outliers to actually say, okay, this person has a cancer or not. But now we're not going to focus on that because that's deeper level. I'm just going to take the introduction because this introductory part. Okay, so two prevalent types of machine learning, of learning from data. So we have the supervised learning, we have the unsupervised learning. Some will go for that and say semi-supervised learning. So just like I just rightly explained now, supervised learning means you already know what output is going to be. You know, you already know, okay, looking at this data, you already know this person has a cancer. That is, you have the foreknowledge of whether that person has a cancer or not. That's supervised learning. But the unsupervised learning, the one that you don't know, that is, it's not a label data. You don't know whether the person has a cancer or not. But it's when we now unravel and look at the patterns, study the patterns in the data, that's when we know, okay, this person has a cancer or not. So that's supervised and unsupervised machine learning. Okay, so for medical researchers, you say machine learning has become a tool. These algorithms, okay, just so given the importance of personalized treatment, all this one I just think that's what I just said the other time. Okay, so we have types of data here. We have the tabular data, that's the one that contains rows and columns. You have the textual data, that's the test. The tabular data can be informed, can be sometimes maybe what you obtain, what you get, that is the symptoms that you get from a particular patient. You know, maybe the person says, oh, I have an headache. Oh, you have an headache, okay, yes. You have maybe rashes, yes. You've been coughing for some time, yes. You know, those are tabular data. And sometimes it goes on and on to floating value. So sometimes it's not just real value, sometimes it goes on and on, and move away from the Boolean data types we know to the float value data types. So we have the textual data. Textual data most of the time is consultation, doing consultation. You know, when you ask the patient, hello, how are you doing today? Okay, may I know how the degree of what you're feeling? Is it very high? Or, you know, can you describe the place? Can you describe, okay, this is where I'm feeling the pain, maybe I'm feeling the pain around my neck. You know, those are textual data. And all this data, we put it in something we call electronic health records. Electronic health records. Some are written, some in underdeveloped world, you know, sometimes in Nigeria, you know, some are written, but some hospitals, most hospitals, even in Nigeria, in Lagos as we speak, they're using electronic health record because they will take they would say, oh, okay, this is what the person did. You see the doctor typing, those are textual data. Then image data, that's a CT scan. MRIs, then X-rays. When they see that, oh, this is really, maybe they see that it's not a matter of, you know, when you said you are feeling the pain, you are feeling that the pain is really extreme, or your chest, you don't have a clear airways, you know, on your chest. That one, you know that definitely you're not going to go through the normal textual data, or I want to start typing, or maybe give that person antibiotics, you know, because imagine if you're saying you're having heart palpitation, you know, that's your blood is just pumping and pumping, you know, that kind of thing. Then that one you have to go for image data. So medical data can be in any form of these categories. So I said electronic health records, administrative data. Sometimes we find our patterns through administrative data. You know, maybe the person is entering, you know, the person was maybe the way the person is even standing, and the admin, you know, the first does the vital statistics, you know, and just notice, oh, the person is not standing straight, the person is not doing this one. Those are administrative data, you know, to that, they call it metadata in data science. Then claims data, then patients disease registry. Claim data can be in any form. Sometimes insurance claim, you know, maybe the person has already disease but couldn't afford the payments, couldn't afford the payments for the treatment when he first came, you know, the first diagnosis, you know, that can be in form of claim data. So if you check the links and look at it, maybe you've seen that maybe your data is not really giving you what you need. Sometimes you go to claim data and say, okay, oh, the first diagnosis, when this person first came, what happened? You know, these are other ways of getting whether somebody has a cancer or not, has a cancerous disease or not. Patient or disease registries, health surveys, clinical trials data, trial data, those are the ones that the doctor actually perform, you know, real examination of the patient. Okay, so moving on, the methods for handling data mentioned. So I talked about three basic types of data here. So tabular data, you know, we can use this support vector, machine or model, that logistic regression, linear regression, random forest. we have different types of method in handling tabular data. That's the truth. But I know that this one is going to serve as a point, at least for you to read more about all these methods. So the textual data, so we have the NLP, that's what we basically use. We have the biotopic transformers, we have different types of topic modeling that we can talk about, what they're bending, you know, different. They are all under natural language processing, because you can use the word of mouth to actually say whether somebody has cancer or not. Then the image data, not, yes, basically categorized here. Yeah. So the image data too, deep learning method, that one we use deep learning methods. We can use machine learning for image data, except if we have extracted it, if we have extracted information from that image and save it somewhere, because sometimes you can get the pixel analysis and maybe you're trying to extract, you know, you're trying to, what's it called? You're trying to convert, look at the points, you know, convert it maybe to pixel or pixel modulated form, you know, to just say, okay, this is what you mean, or this is what this image says. But if you're going to work on the image, then you go for deep learning, and that will form our second part of the lecture. Okay, so materials needed for cancer diagnosis. Data. You can't work without data. You just have to have data. And you can access that there's so many data repositories all around. But Kaggle, I know that Kaggle is free. You can find some cancer data, cancerous or cancer data on Kaggle. Like the one we are going to use for the practice section is found on Kaggle. You have TCIA, that's the Cancer Genomes Atlas. We have PCDC, that's for pediatric commons, that's for babies, children. You know. Then Senodo, yeah, Senodo still has a lot of data on cancer, depending on the one you're looking for. So make use of notebooks too. Notebooks, not the physical notebook that we know of. We are talking about the what's called the electronic notebook. You know, that's where we write our programs. So we have the Kaggle notebook, Google Colab. This one are all free notebooks, but you have to make use of internet. So like I just rightly said, internet. Then GPU, when you're working on deep learning, you just have to make use of GPU. You know, especially when the image size is very large, you make use of GPU. Okay, so now I told you I would really be fast. So I'm just going to go to a notebook session, the session that we have for today. Okay. Or before we move, do you have any question before we go to the practice section? If you have any question, you can just quickly treat that before, so that we have an idea of what we're doing here. Any question?
I have a question.
Yes, please shoot.
I want to ask about SVM.
Yeah,
What's the meaning of SVM?
is a model. Is just a type of model for, you know, just like we have linear regression, we have logistic regressions that support vector. That is, you vectorize the data, you know, divide it. Okay, this like something like you are selecting a feature. You're saying, okay, these are the features, these are the labels. You know, they all work in different formats. You know, they have the distinguishing features under it that you can make it depending on what you're trying to arrive at. Do you understand? So it all depends on what you're trying to arrive at. It depends on the type of data you have at present. So I think so you have to read on it. You have to get to know it and say, okay, because like we have the linear, we have the logistic, we have the random forest, we have the Bayesian model, we have different types of, so it's just a model under machine learning, you know, just for you to, for model training or for training your data.
Thank you.
You're welcome. Okay, so do you have any other question? This class is just a pointer, you know, it's just an introductory class, you know, so that for us to know how, and for us to know that it's not that it's impossible that you can arrive at this, you can get it. So I think so when I will send the slides for us to just read and know more about it. So I will just go to the class briefly and to the practice section. Okay, so this is the practice section. I think I even want to send, let me just send the, so hold on, please. I just want to send the slide, and so that we can, let's see whether I can send the slide. I don't know whether you guys have to access. I need to access. Okay. But you have to, the data, I don't know if you can have the data, it will really be nice. Okay, so this is the slide. I think I need to get a short form of it. Okay, maybe later I will just send the slide. I can send it through Ashraf. Okay, so let's just go to the class. So, okay, so this is diagnosing breast cancer now using machine learning. What would we first do? We import the necessary libraries. Pandas is just is a method for when you're working with a data frame. That is when you're working with rows and column. That's pandas. So the NumPy is for calculation. Then Seaborn is for visualization. Matplotlib 2 is for visualization, just for you to have a visual of what you're working on. Okay, so I already have the data. This is the data, so load the data set. When you import the necessary libraries, then you load the data set. So I got this data, like I said earlier, from breast cancer, Wisconsin. We have so many data sets too on Cargo that you can have access to. Then for practice section, I think you can go to my GitHub. If I share my GitHub, so you can go to so many codes too on GitHub for you to practice. Okay, so here now we are importing it. So we import this. That's we load the I loaded my Google Drive. So so first import. Here I'm using Google Colab. So this notebook I'm using the Google Colab. So I load my drive. So drive already mounted because I had already started. So this is it. So this is the data now. Just to have a look about our have a look at our data. That's it. We call it exploratory data or data processing. That first step when you're working with any form of data, because you have to make sure you don't have null values in your data. You don't have what's it called? You don't have null values. You don't have imbalanced data. You know, these are little things that we look at, little details that we look at and can affect our results. Okay, so looking at it now. So this is the head. This one just showed the first 5 details. And if you want to see everything inside that column, you can just say df dot column. Sorry. So these are our columns now. So, and if you want to look at the details, so you can see the ID, the patient ID. This is the diagnosis, whether that person, whether we have the malignant or benign. M stands for malignant. Malignant means the person does not have cancer, and benign means the person has cancer. Sorry, please. Just want to check something.
Benign is not having cancer.
Person has cancer. No, the person do not have cancer. Malignant means the person has cancer.
Okay, yeah, I thought as much.
Yeah. Okay, so looking at it now, so this is the diagnosis. So look at the main now, the radius main, the texture main, the perimeter main. Then, so these are just the details of what we got or what the data is all about, just for us to have a feel of what the data is all about. Okay, so this detail that's looking at the last 10 value. And if you want to get the detail, maybe detail of the data, just to have an idea, you can just say df dot shape, just for it to show the column. The row and the column. So here now, can you see the row? So we have the 569. That means we have 569 patient cases that we have here. It's 568 here because it started from 0. Then we have the 33 columns. That's the 33 features that we got from that patient. Okay, all this one is just for us to have an idea of the kind of data we have here. So DF is not this checking whether the data we have the empty cases or not. As if we have the empty inputs or not. Okay. So this is information about the data. So it's a df.info. That is, you want to know the details about the data. You know, all this one, they are just, you could see it shows non-null. Why it's showing non-null is because we are using cargo data. Cargo data most of the time it can be might have been pre-processed, but sometimes data is in its raw format don't always come like this. Sometimes it come in a very dirty format. So all this EDA, so knowing how to clean up data is another skill on its own. Until you have to clean all the data. But because we got the data from, because if you say we want to do EDA or clean data post-processing a day, sometimes 2 weeks, we are not there. That's the truth. It takes most of the time because if you don't clean up data, you might not get the right results. But why is so, like what I just said now, non-null. Non-null means no empty value. So you could see that's why it's saying 0, 0, that is you sum all the one that has empty, the column with empty values. So you could see that none. So we have 0, 0 or true, which except the unnamed 32, that's its own name. So we can make use of it. So unnamed is it doesn't have a head. You know, sometimes when they are putting the data, you just mistakenly add another row, you know. Yeah, so it can be anything. So that's why when you're collecting data, you have to be extremely careful in collecting data or data correction. Okay, so we dropped that one, this one, you know, the one that we are talking about, that one name, so we dropped it, you know. So this is it now. So this is a 2 column. Sorry, 6 hidden cells. So I didn't go through that, what's it called, the steps we have, you know, looking at our time constraint. So, but now I think we can get the steps. So the first step, after data collection, you know, when you're coding, if you're talking about coding, you import your data, the important libraries. So after importing the library, then you have the import the data set, that is load the data set. Then after that, look at how to clean up the data, you know, and that normally takes most of the time as a data scientist or AI engineer. So then you go to the feature selection, you know. Feature selection, so this is where you really need to have an idea of any use cases you are working with, you know. There's a general belief that most AI doctor does not have, they don't know much about what's it called, AI or AI engineer generally. They don't know much about what they're trying to, or their use cases in programming, you know, because most of the time, I'm going to call, we know the programming, we know how to program, but when you're using it for cancer diagnosis or when you're using it for medical disease analysis, you have to know more about it. Like now, you know, when I was mentioning the benign and malignant, sometimes, you know, you get confused. Sometimes it's like, oh, but unless you read and know about it, you know, when I say malignant, oops, you know, that kind of thing. So you have to know about the use cases. You just have to read and know everything about it. Okay, like all this texturing, if you look at this data, looking at this data, these are what we have extracted from an image data set or image image form, from image form, you know, so, or image modality. So this is what we extracted from it. If you look at it, the diagnosis, the radius mean, the texture mean, the perimeter mean, area mean, those are the things that we extracted from it. So if you're going to be using it for cancer diagnosis, that means we have to know more about what or the kind of cancer we are dealing with in. Okay, so and that's when explainability of data sets or explainability of AI models come in. So I will encourage us to really read more about that. Maybe we want to be using it for cancer diagnosis. Okay. Okay, so what we do now, we selected, we leave the ID. Most of the time when we are working with data sets or when we are working, we have to remove the ID because ID can implicate and there's this sensitivity from the data or from medical AI side that you just have to remove the ID. You are not supposed to expose the ID of any, what's it called, of any of your patients. Even after you expose the ID one-on-one, you know, you talked about it one-on-one with the company, but you are not supposed to expose it out there or put it, maybe you're writing a paper or you want to put the results out there. So I remove the ID, so it's starting from number 2. So this one is selecting this array. So you know about array 2. So this one is selecting from 2. That's feature number 2. That's from diagnosis, which is our target. So sorry, can somebody tell me the type of data from what we talked about supervised and unsupervised learning or machine learning. So can somebody just tell me, looking at this, can you just tell me the type of data we have here? You've been following. Can you just tell me the type of data you have? Supervised. Thank you very much. Thank you. That was awesome. Supervised because we have diagnosis here. So we already know that patient ID has been diagnosed to have cancer, you know. Do you understand now? So what we now do, what we normally do, what we do is that after feature selection, so now we can see, you know, we said we select it from our 2, that's from diagnosis. So they go number 2. Shoot. Sorry, please. Sorry, please. I'm in class. Please. I'm so sorry for that, please. Yeah. Okay, so selection from, so we select it from 2 to number to row 32. Shoot. So excuse me, let me just quickly let them know that I'm in class, please. Sorry, I'm so sorry for that. The children are also sometimes we get some calls like that. Okay, so now, so looking at it now, so we do our feature selection. So we are talking about the targets now. So our target is Y. So that's the number 1. Can you see? So this is number 1. We are selecting from radius name. So these are our features. So we do the features selection, and we have the target variable. So our target variable is our diagnosis, just like I rightly said. So I printed it, you know, just for us to have an idea of what we have here. We can play around it when we really know about data, but because I just don't want us to, I don't want to take your time or take our time. Okay, so looking at it now, so you have the label encoder. Okay, so because machine learning cannot work with strings, so or programming most of the time it works with float or bin. So we use our label encoder to change this to 1 and 0. So the malignant will show that is 1, the benign will show that is 0. Malignant means you have cancer, benign means you don't have cancer. That's another thing you have to take note of when you're doing your target, when you're looking at your target variable. So that when you want to go and predict your score, you should be able to interpret it well. That's what we call it modern interpretability. Okay, so you can see now that so we use our label encoder. We have so many different types of encoder. You know, we have the 1-hot encoder, a label encoder. We have categorizing tasks. We have so many types of encoder that we use for this kind of work. So looking at it now, so Yeah, you could see that we changed it to 1 and 0. So you could see our M is 1, while our B is 0. Okay. So now we are going to model training because we already have it now. So these are model training. We want to train our model. Look at the random states. All these most of the time what we do in this you know, you divide it into train and test. You know, you already have an idea of, okay, whether you divide the data, you already had an idea that, okay, this data has cancer or does not have the cancer, which is the cheapest and the simplest and the basic form of machine learning, you know, for diagnosis. So what we now do is that you divide the data set now. You divide it into, sometimes it might be 80 to 20, sometimes it might be 90 10, sometimes it can be 70 to 30, depending on when you've unraveled and checked that type of data you have. So now here we use the 90 and 10. You can see my test size is 0.1. That means I'm using 10% of the data set to train or to test my data. So 90% I will use it to train. Training means you are training your data. You want your data to behave in a particular manner or in a particular form. Yeah. So, and you can use any form of model, and that's where this SVM, what's called logistic regression, linear regression, and the rest comes in. You know. So now, yeah, now, as most of the time we use SVM, you know, but sometimes SVM might not be the perfect fit, and that's why you have to train. You have to do different types of model to get the best, results, the best accuracy from your model training. Okay, so now looking at it, so you use, like I was saying, so you transform it. That is, you transform means you're changing it to the form of standard scalar. This is the model we are using here. You see, we use standard scalar, we use random forest regression. I think we use SVM here too. So we use the standard scalar here. So we fit it now. So this is our train, that's the 90%. Because now you know the 90%. So of course, when you put the 10%, 10% does not have anything. 10% you've already deleted, that's you already removed the what's good, you've already moved that target variable. So you'll be able to predict based on that 90%. And that's what machine learning is all about. Am I making sense? I hope I'm not just talking to myself. Are you guys getting me?
Yeah.
Yes, ma, we are getting you.
Oh, thank you very much. Okay, so this training now. So we are using the 90% to train, then we are using the test, that's 10%. Okay, so now we are using random forest regressor. You can use different types, you know, just to, and sometimes we use what's called tabular form, you know, to just categorize the type of model that we've used, you know. So use the n estimators, you know, just to estimate our n variables, you know, random states, 0, all these ones are just they're just literally to we call it fine-tuning, model fine-tuning, you know, to just fine-tune our models, you know. Since we don't really have issue with the data, because the data is from cargo and is being pre-processed. Some data it won't be pre-processed. So you spend time too in fine-tuning the data to what you actually want. Like part of fine-tuning is that one that we did, that we convert the encoder to 1 and 0, you know, to use it to convert, and sometimes and to check our array as to pick for feature extraction and the rest. Okay, so you can see now, so we've run it now. Don't know, yeah. So we're here now. So we've run it, so this is it. So so we're using accuracy score and the F1 score. It depends on what sometimes in images we use AUC, we use AUC too for this one, accuracy score. It all depends. Sometimes we use the ROC, the diagram. We have a diagram too for that. So you can see the accuracy now. So now, so this is the model, this is where we model it, this is the model session, this too, you know, you've already modeled, so it fits it, so this is the model session. So now you are now predicting it now. Okay, so looking at it now, you can see the accuracy score of the white test, you know, that's the white, that's the predict score that we're making use of here, or predicts data that we're making use of here. So looking at it now, so that's our test data. So look at it, it got 0.929, which is very okay, fair enough. Sometimes it might not be that answer. You know, I told you that we use a preprocessed data. We use a data that has already been cleaned. If it's not been cleaned, sometimes you can get 0.6, 0.5. And when you're talking about cancer diagnosis, now we are talking about medical data, is how can we call it? It's very important for us, you know, to get our accuracy between 0.9 and 1.0, because here we are dealing with lives. And the non-medical AI don't want to hear story. That's the truth. So they don't want to hear story whether this or that. You know, that was, I said, sometimes, you know, we spend 2 weeks, 3 weeks, you know, cleaning up data and making sure we get what we want. So looking at it, so this is it now. So this we make use of this another model, decision tree classifier, you know, just to see whether we are really getting it or not, or whether we know, because you can see that we make use of 2 models here. We make use of the random forest regressor. We make use of what's called standard scalar, and you can see that scores are really very high, 0.92, 0.91. All these ones are good scores. Okay, so now we are now using it to predict now. So we make use of nice base too. All these models are models we need to read. We touch each one after the other, you know, to actually know the one that is perfect for, because sometimes you might use linear, but the only way you can get to know is when you've tested, you know, with all these models. And using machine learning is really easier because it's just 2 lines or 3 lines of model training. You know, just put your 2 or 3 lines training, you know, it will give you what you really want. When you now tabularize it, but sometimes you have issues. So when you have issues, that's when you go back to your data and go and check whether you are really getting it or not. Okay, so looking at it now, so you could see that, so now we are looking at our accuracy. You can see that you really got a very good score. So you print your Evans score. So you can see our score, which is, you know, you could see, you will remember the one, that's the first data. The first data is 1. No, talking about the test, you know, we are talking about the 10% now. Except if you divide it, you know, sometimes we divide it. But looking at the accuracy, you know that it will just only, it would only predict few incorrectly. That's it. It only predict few incorrectly. Because sometimes it will still predict some few incorrectly, you know. Even when it's 1, when it's perfect, maybe you can just predict 1 incorrectly or 2 incorrectly, depending on the image size or depending on the data size you're working with. So you can see, so now we now want to use K-neighbors classifier. K-neighbors classifier is used for non-supervised data sets, you know, just to know our neighbors, just to divide it into cluster. But you can use it for supervised, you can use it for unsupervised. But we just went ahead, okay, let's even have an idea whether it's going to work, you know, whether we are really on point or whether we are really getting what we are doing. So we divide the neighbors into 8 that is different, okay, you know, based on the data, based on the features that we have. So you could see now the accuracy score, it was CI. We are getting all these scores because it's a pre-processed data set. And so if you now want to predict, you know, you can now pick it one after the other and say, okay, looking at this data, this, what's the score we have? What's the score we have? Can you say this one has a cancer or not? So I didn't get into all those details, you know. So yeah, so I think that's what I have on introductory aspects of diagnosing. This one we are talking of breast cancer here, part of the diagnosing breast cancer using machine learning. Okay, so this, excuse me. Let's see. Okay, sorry. Oh, supervisor. Oh, thank you. I just saw you got your. Sorry, I'm trying to. Okay. So, and that is what I have for this class. So, don't know whether you can use 20 minutes to, I would like us to launch and start using our, maybe we can get a data set and can we just launch into practice class now? So that's what I have for this class. So, so how many are with me to practice now? So do you have your system, internet? Yeah.
Said even you laughed, presenter.
You say what?
I said even you laughed. I believe it's something we can know, but these things look so fast. But okay, I want to ask this notebook. Is it we have to download it or is it a website platform? Like is it a website?
The notebook. No, you don't have to download. Let me just post it. Let me just post it. But you can just have a, no, I just want us to have a feel of it, you know. Let me post it directly. If you have a system, oh, see, somebody is set and you are still talking about, let's start, please. Okay, so let's go, let's start. So let's go to the lab.
Even if
I didn't
somebody
get
said,
you.
I think you need to carry majority of the class along, man.
Yes, okay,
Is
yeah,
it,
let's practice, let's start. Let's start because
is
you're
it
still going
Jupyter
to finish
notebook we
the
are
exam.
using?
I didn't get you.
Is it Jupyter notebook we are using?
No, use Google Colab. That's why I'm sharing the screen. So let me share the screen so that you just follow me. Even if it's just to import data, that's fine. So let's just go to, yeah, even if it's just to import data, because once you get beyond that import data, you know, okay, sorry, this is my first time. I found it on Claire. Is that the notebook? Yes, I've shared the notebook. Don't worry, it might not be everybody in the class. Don't worry. It might not be everybody in the class, but let's just start with something, at least if it's that one that we're able to do, I think that's fine by me. Okay, so we need access to the Google Colab doc. Can you make it free access?
Sorry, I was going to ask a question. Is it very much compulsory we make use of the Colab, or we can make use of Jupyter for the sake of other time?
Yes, you can make use of Jupyter. You can make, you know, I told you, I mentioned you can make use of Google Colab. Can you make use of Cargo too? Do you have a Cargo notebook? You know, you can make use of Cargo notebook. This is an example of Cargo notebook. This is the data that we used, you know. We can just start briefly. You know, if you start, okay, you need access, don't worry, let me download it. I will download it and just post it. Let me just download it for you guys, you know, to just, excuse me. There's so many notebooks that you can, I can share my sheets up. You guys can just, you know, just download, upload it on your own notebook, you know, just try, and before you know it, sorry, I'm trying to share this.
Okay, hello, please,
Can I
ask a
share?
question? Can I ask a question, please?
Yes, please.
Okay. Which skill do I need more importantly? Do I need to learn machine? Do I need to take a course in machine learning, or I should take a course in data science? Which one would make me, which one would give me expertise in this, so that I could understand it better?
Data science is the overall or collective name for machine learning, deep learning, all the rest. Do you understand?
Okay.
But if you now want to go to specialized, like this one, if you want to go to specialized, then you go to machine learning. You pick it one after the other. There is a specialized course or training on machine learning that you can make use of on Coursera. What I
Yes,
do,
I saw it on Coursera. Yes, that's why I asked.
yeah. So that's a fantastic idea, because what I did was that I think I'm just 2 years into this. it was during COVID lockdown, I switched to data science. And what I did was that I got, I didn't mind the cost. I went for the specialized training. I think I can see, maybe I can quickly Google it and get that for you guys. So I went on specialized, that's a training for 3 months. It's supposed to be 9 months. You know, it's supposed to be 9 months.
Okay.
But I squeezed it because I didn't want to pay more than that. Everybody know what dollar is in the country. So I didn't want to pay more than that. So specialized data science. So I squeezed it and I was able to do it. So I squeezed everything. Yeah, I think this should be 8. I don't know, that's right. They might have changed it, so you can never tell. You know, they change their course or module every now and then, so you can never tell. But I remember that it has 9. It has 9 courses under it. Actually, it was IBM. Was IBM? Yes,
Okay,
was provided. So I don't know. The IBM, John Hopkins, there are plenty like that, that were just on it. It was a 9, because I don't know whether it's this one. I don't know whether it's this one, but it was a thorough one. As in, you know that when you're doing this kind of thing, you have to be self-motivated and yeah. Nobody's going to tell you, so you just have to motivate yourself and just get it out and get it right. So that was what I was doing. So I did 9 courses, 9 courses in one. So I did it for 3 months. So like that's a master's track. Yeah, that's a master's track. But that was the beginning of it. After that, then that was when I started moving on and on, graduating to, I think I subscribed towards data science. So there's so many things. There's so many. I think let me just say Coursera. You can make use of Coursera. You can make use of towards data science. I can just be grabbing the link and just send it toward data science on Medium. It's part of Medium. If you want to be fast in this. So I did a 1-year subscription. I wasn't minding the cost. You know, I did a 1-year subscription to it. I was practicing. Then Cargo too. Cargo has free training. You go to Cargo, you have so many free training on Cargo. Let me go through that. Let me just whether I can get in the links out for you guys. It seems Cargo, yeah. So Jupyter, I don't really like Jupyter because sometimes it hangs. You know, if you're not on a very good Wi-Fi or Wi-Fi, it makes your work it makes it. I would rather use VP. I have a so I would rather use my VP environment. I have a VP environment, but sometimes it can be complicated for those people that are still learning how to code, because you have to put everything in what's it called, in classes. You have to be class, function. You have to write functions for each, so you can see it. So Cargo, all these short courses, you can go to those short courses because Cargo is for data scientists, and there's so many, you can say, beginner, intermediate, advanced. These are just start from somewhere. Just start from somewhere, as in there's so many courses that you can make use of on Cargo too. On Cargo. Then towards data science, it's free. But it's not free. I think you can have access to few, is it three something per month or something, But me, I went to premium. When you want to do something, you just have to leave the cost, and just go for the premium. So that was what I did. Let me see the toward data science. Maybe I can get that link out for you guys too.
Okay, my second question, ma.
Yes, sir. Yes, sir.
Okay, my second question now is, what are the career prospects now? Because how do you, is it, most times as Nigerians, let's be sincere, you want to make out money out of something. Because I won't spend all this money learning and it's just to publish papers alone. You also want to see that bring in some money for you. So can you give me an idea of what the career prospect is? If I learn this machine learning, I use it for cancer diagnosis. Do I have jobs opening or things like that?
Loads of jobs, as in loads of jobs, but might not be in Nigeria. You
Yes,
know,
yes,
you just
of
have to
course.
announce yourself. You just have to announce yourself, really. Like, I have so many, if not because I'm going for my own grad school. That's why I can't get it. As in, I can't promise anybody, but I already have another job. Yeah, I already have another job that I will be doing once I start grad school. And it will be paying me exact money grad school will be paying me. And I already have some too, you know. Most of the time I will just keep posting them that sorry, you know, or sometimes I discourage them. You know, when you get to an expert level and they can see that you really know what you're doing, you know, they will start calling you for interviews. That's the truth. They will start, but it's a LinkedIn that you can use because Nigeria has not gotten to a point where we use AI to diagnose diseases or to diagnose cancer. Yes, some are getting it, like the GE care. GE care came, you know, like I was interviewed for GE care, but where they were taking me to, it was really far. I was like, oh, no, I cannot go to GE. I cannot go. That it was in the northern part of the country. So I was like, oh, no, I cannot. My family is not there, you know, and so many other things. So imagine if GE care takes you in, you know, GE care is an international company. And I'm sure they start with 1 point something million, if not close to 2 million, yeah, to pay you if there are no internal barrier or internal what's it called? You know, sometimes we Nigerians, we are the ones who always spoiling yes, businesses for us, for outsiders. Oh, why they want to pay? Why they want to pay out this, you know, Nigeria is in recession. I'm sure even if you give out this or this one, she will be willing to take it, you know, that kind of thing. You know, but it was a trade-off between the insecurity and this one. That was I had to discourage them. So these are jobs that I can take. The Mayo Clinic is in Nigeria too. They're based in the US. So that means for all their trainings, they'll be taking you to the US to go and train. And another thing, once you put your profile out there, you are consistent, they know you have a brand, they know that this is what you actually do. You know, there's no barricade that is as a deceiver, you know, you just keep rising and rising and rising. So there will be so many people that will call you. They will private chat. They will, like me. I don't sell. I don't send that. Oh, I need a job. No, I don't. I interview as in I just did one interview 2 weeks ago. I was just doing it to play. You know. Sometimes it's just for you to have an idea of what you actually want to do. You know, just to have an idea of the requirements. Are you still on point? Are you still getting it right? So I attend those interviews, you know, just for the sake of, you know, just to prove a point that I'm still doing something. So that's where I get those interviews, because I know that I will start grad school soon. Do you understand? So
Yes.
there's so many jobs out there, and you can combine, even if you're going to do research, you can combine it. That's one beautiful thing about it, because at the end of the day, you're working remotely. They send the data to you. I think I worked for some last year. Apart from Obdena that I freelance for, I use Obdena to work on projects, you know, just to know more about, because I know that I didn't have MD background. I don't have medical background. I have what's called computer science background. So it's like you jumping, you know, you are moving from the transitioning phase. You are moving
Yes.
entirely from a phase to another phase. So sometimes when I was just like, oh, but what I did was, you know, to really balance or to really cut across and be on point, I had to read. It was a lot of work. So there's so many jobs out there. So many jobs. You can work as a medical AI engineer. You can work as a machine learning engineer. You can work as an AI doctor, AI radiologist. Yeah, you know, so many out there. You don't
You know
have to
why
move to that country. They just send the data, they send what they want to you, and you just grab it, give them the data. Okay, this is what, and you present your results to them, and they'll pay you, and that's it. Yeah.
Okay, Matt, thank you so much, Matt, because the essence of joining this webinar actually was because of this topic was what attracted me, because I'm into cancer specialty. So
Oh,
I really got interested in this webinar because of this your section you are handling today. I have not had it before, that there is an aspect of this, there's an aspect of cancer that you can use machine learning. So that's why I became interested in the whole webinar from beginning to the end. I was really interested in this aspect, because I've not had it before. You know, most times in Nigeria, much information about what is happening out there,
Yeah.
the recent trends of things and all those stuff. Can I follow you on Twitter? Are you on Twitter? Can I follow you on Twitter?
I'm on Twitter, but I'm not very active. I'm more active on LinkedIn. I'm more active.
Okay.
I can just grab my LinkedIn detail, and it seems they're not going to do class session. So maybe we'll do another class for that. So let me just get my LinkedIn and do like just send the yeah. Maybe we'll be able to do the practical session for that because we have another session now.
Okay, man. All right. Thank you so much. I really appreciate it, man.
You're welcome. So that's my LinkedIn profile.
Okay.
LinkedIn can just follow me because it looks as if I'm getting too much invite nowadays. And I try to do the people that are already in my feed, but it's fine, it's okay. Yeah. So okay, I'm interested in I've dropped it. I've dropped the LinkedIn bio. Yeah. Can just follow, at least you'll see some of my work. Okay, I can just send it GitHub. Let me just, although my GitHub sometimes I don't, because now I'm working with some personal data. I'm being careful of putting some data out there. So it's just the old one that you see. You might not get the present one, because now I've started working. So I have to be conscious of the consent because you have to sign the consent form that you're not going to divert the information out there. So sometimes you might not get but at least this one will give you the introductory aspect. You get the introductory aspect on GitHub because the cancer extraction is deeper than what we see it as in is level by level, stages by stages, constant practice every now and then. Yeah, it's not really something easy like that. Sometimes it's a lot. It takes a lot. It's because I use pre-process, so it's not just what we see, but you can start from there. You start from somewhere. I'm sure we practice. I've forgotten his name. That said, if you want to get expert at something, just keep practicing. You can do 8 hours per day. You can, that time I was doing more than 8 hours. Really, I don't sleep. I work like Jackie, just to get myself abreast of all this and just say yes, as in to really say yes. I'm a cancer AI or machine learning engineer. So I would say we first start with data science aspects, first start the machine learning, the basics first before we go into data. Thank you very much.
Thank you, Ma.
I want a clarification on this. I don't know if you're going to put us the practical session, how to open the web pages gradually from Google.
Okay. I wanted to be before I was being asked loads of questions. So let me just go there. Okay, so you can go to Google Colab. You can use Google Colab. Google Colab, then if you are going to use Google Colab, let's look at Google. When you use Google Colab, you have to learn how to mount your drive on it. You have to learn how to mount your drive on your system. So now go to cargo.com. So I'm there now. So are you there? I'm just going to do 5 minutes on this because we have the image. We are still going to the next session. That's image extraction. Are you there now? Are you there? So if you go to cargo.com, let me just put the link so for you guys. Okay. Okay, so just now get to that cargo. So you look at data sets. Look at that 3 strokes and look at data set because you have to have data before you start. You have to have data. Sometimes you can go through the code. Sometimes you can go through the data set. Either ways, if you go through the code, but
it's asking to register with Google. It's asking register with Google.
Yes, you have to register. You have to have an account with them.
So how do I go about that? Okay.
Sorry, please, can you? I'm not hearing very well. I'm finding it hard to hear you.
Okay. I'm asked to register, so I have to go about the registration now.
Yes, I'm sure some
Google.
others will have done that. So
Ah,
is somebody there? So you just go to data set. So I'll just click on data sets from that strokes. Okay.
Okay, ma, you said we should go to cargo. Sorry, let me
Yeah,
get this.
cargo. Yeah.
Okay.
Or you can just go to this cargo.com to data set. Let me just send that one ASAP. But I think you have to register first. You have to register.
One can register with email.
Yes, just register with any email. Yeah. But cargo is from Google. Yeah, it's from Google.
So Google is advisable, right?
Yes, yeah, it is advisable Gmail. So as not to miss out on all this, because sometimes compatibility can comes into play. So you can look at data. You can look at now breast cancer. Just for to have a, let's go to our breast cancer images. Sorry, I want to get the exact one. Yeah. Okay. So this is the breast cancer images. So let me send this directly so that
You said we should go to new data set, right?
yes, data sets. No, data sets under that three
data
strokes.
set.
Yeah, data strokes. Okay. So set for breast cancer, Wisconsin. Let me
Data
send
Sorry,
that.
please.
Sorry,
Okay,
I'm getting. Is it that?
where are we going now?
You say what?
At the
You want to
interface,
get the
how to
data
start
set?
for today? Yeah.
I didn't get you.
I'm trying to say, what am I going to do next? Now, welcome Sunday. Cargo is ready to
After
learn data
data
science.
set. After data set. Yeah. Okay.
After data set, which of the icon, please? Okay, data set. Okay. Is it data set that
Yes,
we click?
after data set, what else do we click, man?
New data set, ba?
New data set.
After data set, you search for breast cancer. Search
Okay, we
breast
search
cancer.
data set. Okay, breast cancer.
No,
Thank
no,
you, bro.
no. You click data set. After data set, you now search. Click data
For
set.
data,
Then you
okay,
now
breast
search.
cancer.
For breast cancer.
Yes, breast
Okay.
cancer, Wisconsin.
You say breast cancer with
Okay.
cost.
Yes.
With question, that's the one we chose.
Yes, yes.
Okay, thank you.
All right, we are there now.
What happened to our presenter? She seems not to be available.
I think that should
Thank
be
you.
a network issue from our side. So I think we can still proceed with the steps. I think easy to follow, and I will call her to ask what happened. Probably it's a technical issue. So let's go through to the cargo.com and register.
Okay. Are we downloading the data set?
Sorry, please, I have a question. After logging in with your Gmail and you click on data set, are we to download it or I need a clearer
Okay, you have to
explanation?
search for the type of cancer you are looking for. So breast cancer was searched for.
Yeah, you download it. Download it.
Okay, download it.
Download it.
Download, please. What are we downloading?
The data set now.
Once you search for that breast cancer diagnosis, Wisconsin diagnostic, you
Yes.
download the file. You
Okay,
download the
50 KB.
file. Yeah,
That is 50 KB.
yeah.
Okay.
Download it.
Okay.
The data set is zipped, so I guess we'll unzip it, right?
Of course.
Yeah. It's even in Excel format.
She's better.
Please, what am I to search for? Breast cancer image or the breast cancer identification?
I think just search for breast cancer. I think that was what I did. And then you see options of the kind of breast cancer data that is available.
Okay, I saw for data set, prediction, and detection. Which one am I to use, please?
The one with Wisconsin in brackets. Or what are your options?
Okay, yes. Yes.
Okay, you've seen that. So click it. Are you there?
Yes, I've
Yes,
clicked it.
so should I
Okay,
download?
then you download. I mean, it downloads to like an Excel data.
Yeah, I saw it's 50 kilobytes.
Yes, then you unzip it.
Yeah.
And then
Okay.
you have a lot of data in Excel format.
Unzip it with what? I'm saying which one? Is it Excel format?
Yeah, you unzip it like.
With Excel.
Just click on it, like just double click on it. It open the data for you. Like mine is opening Excel.
Okay, hello. Am I audible?
Yes, you are.
Okay. Okay, so person searching for, I think I've okay. Sorry, I'm trying to go back to where we are. I'm trying to get the exact data, so let me go back to my presentation and just get the exact data out. Yeah, so are you guys on the new notebook now?
Okay, we have to also open collab. Is that what you mean?
No, you are not opening collab. I'm trying to get the exact data. Are you on the cargo notebook now?
Yes, we are.
Okay, so you've opened the new notebook, right?
In fact, we've downloaded the data set.
Okay, so now we are on it now. So what do we do now? So if you want to start now, so you just import. What do we import? You can just be copying. You can, if you, since you already have the notebook with you, right?
Yeah, we importing.
Okay, that was asking.
I've not seen import.
Yes.
Okay.
And we have to be on the collab.
No, don't get
Because I
since
can't
we are using
it.
cargo, we are using cargo here. Okay, I think I've done that. So let me see whether I can just add that one to our call so that I can just be able to open it from the system. You should be able to open it. Let me see, please.
You know, we
Okay.
unzip the file. We unzip the file from cargo.
Oh, that's not, I don't think that's a problem. Once you're cargo, no, we are using cargo, we're not using actually it seems like I'm not I'm trying to send a message or attach something from my system, but the button is not activated. Or maybe I send, okay, let me send it to you. Let me send it to you so that you can just send it, please. Thank you.
I think it will disallow. Okay, if you can send it to me, then I'll send
Okay.
it to the Telegram group.
Okay. Okay, let me do that.
Is this different from the one we downloaded from Kaggle?
No, that's data. Data is different from the code.
Okay, this is the notebook.
That is, yeah, the code book, the notebook. Okay, so I've sent it.
Yeah.
Oh,
yeah. Okay, so you can just now start copying, if you are having issues. But for me, okay, you just say import. That's what you first do. Import pandas, because you are going to work on tabular form. Import pandas as PD.
I'm lost.
The file has been sent.
Okay, the file has been sent. Thank you. I'm supposed to be closing this class right now for Medicare image analysis, you guys.
Diagnosing breast cancer NKC. Is that the data?
No, that's not data. That's IPYNE.
Data.
That's the notebook. So what you do, no, don't just open it anyhow. Open it, maybe you should open it with a Chrome. Open it with a Chrome, or if you have a Jupyter.
I look at data set.
I didn't get that.
Are you talking about data set?
Data set. Data set is already, see your data here on the Kaggle. You don't need to download any data. You know, that approach that I used is for us to enter straight into and have a data set here. Can you see? So these are our data. Can you see? All we need is to just add our data now.
But the truth is this: if you can quickly recap, let us enter again, because I'm not following.
Lost.
You know what? I think that
the process was simple.
Yeah.
Let me quickly do a summary. So when we entered into Kaggle, what we did into Kaggle was to access the data set from Wisconsin. After that, on that, the notebook opened. So what you now need is the IPYMB file, which has been sent to us on Telegram. So for the downloading or not downloading data set, you don't need to download the data set. So all we need to do is just to follow the command line as it's being typed on the screen as we have it now. Import pandas as PD. So then all you need to do is just follow the process. So then when it's the time to handle with the data set that has been sent to us on Telegram, would also be notified on how to do that. But as she has said also already, you can open it with Chrome. So it is
We
very
can
easy
even
to
open
work
this
that way.
Yeah, sorry, thank you, sir. So we can even open it, you can just even upload it. See, since you already have that what's it called, the notebook with you, you can just import, go to this, just import it so that we don't use time on coding and we forget the medical image analysis. So click on this file, go to this file, click on file on your notebook, the notebook that you already have now, click on file, then go to import notebook. Import notebook.
Excuse me, ma. The challenge I don't have here is I was trying to ask that the notebook. How do we get the notebook? For example, now I'm on the site that got the breast cancer Wisconsin. So I'm thinking, okay, is there a particular platform?
Okay, well, if you're on the site of the breast cancer in Wisconsin, this is it. Sorry, please let me quickly just this is the breast cancer Wisconsin here. Sorry. See, if you are here now, leave my own background now. Leave my own background. So if you're on the breast cancer Wisconsin, maybe this one. Let me say, I will just use, okay, this is it. So here now, if you are here now, this is the page now. So you just go to these 3 strokes. See the 3 strokes on your left hand side. Go to that 3 strokes. Yes. Oh, sorry. I'm sorry for that. New notebook. Click on this new notebook on the right end. Can you see the new notebook?
No.
Can you see the new notebook?
Okay, it's there beside the download.
Beside the download, yeah. Before you get to download,
okay.
So just click on that.
That yellow
taking you to the long process. So can you see now?
Okay, it's bringing Kaggle Gold on the tab.
Yes,
Yeah,
that is it.
notebook
That's your
90
notebook.
this 0 for my
That
own.
is a notebook. So you can now rename it if you want to rename it. Anything you want to rename it. Can you see where I rename it? You can just say breast cancer practice, breast cancer, sorry, cancer underscore practice. Did you get that now? So
Yes,
that's
ma'am.
your
Yes, ma'am.
notebook. That's your notebook. Then if you now want to upload, because I don't want to take us through the detail now. If you want to upload, just go to your file. So go to import notebook. That one that Asha sent. So you just go to import notebook. Can you see?
Okay, what are the one we downloaded?
That's the one I'm talking about now.
Okay, okay. If it's on our system, it will come up, right?
Yes. So go to import from files. Have you clicked on import, right? Import on those 3 strokes again. So
Okay,
it will take you
file.
to import from file. Now go to browse files. It will take you to your system now.
Sorry, please. Sorry, please. Okay, now file. You have new notebook. Import notebook. What's there again?
Wait.
Download
I will go
notebook.
back now. No.
Okay.
Import notebook. Click on import. Import notebook.
Okay, import notebook. I've clicked it. Yeah. Okay. I'm in this page now. The one you're saying.
Okay. Then now go to browse files. Click
Okay,
on browse
browse
files.
files.
Then now go to. I saved my own on desktop. So go to desktop.
Okay. I think mine
So
is. I don't even know where I
yes.
spent. Okay, I will just put the name. You can search it.
So just click on diagnosing breast cancer now. So I've
Okay,
clicked on it. Have you done that and open? So it
I'm trying to
automatically.
look with the name I used to store it then.
Oh.
It was on Excel that it opened for me.
Okay. No. The data is different from the one Asha just sent. That's the IPYMP.
Oh, that one is different.
It's different. The data is that data set that you guys first downloaded. I did ask you guys
Yes.
to download. That's the data. It's different from the notebook.
I have of the notebook.
Yes,
Oh.
the notebook is the one Asha just sent now.
Okay, that's what we use here now. That's the notebook we want on this app
Yes.
stuff. Yeah, the challenge I now have now is that I'm using a system and my Telegram is not on my system. So how will I get the one he sent? I'm sorry, but I think it's
No, you can just copy it and mail it to your email address or something. It's a notebook.
Okay.
Once it did not change
Okay.
the format has to be in the IPYMB because you can either have PY and IPYMB. But IPYMB is a general format which you can upload it on any Python notebook. So now I've uploaded it. See, can you see it here? So I've uploaded the notebook. This is everything that we've been talking about since. So you can run all. I just wanted to take us through the shortcut. Just run all because I have to end the class by 12.
Okay.
So are you there now? Is anybody there? Is anybody there at all? Has anybody gotten to this page at all?
We understand it as well.
Yes,
Yes,
I've
I've
got
gotten there. I just
Oh,
had to
good.
drag file. I just dragged from my this
Drag,
and then put it.
awesome, awesome. You see, those are techie people here talking.
We're all doing it too. I'm
those
not
people have been
joking.
working.
It's
Those
because
people have been
Okay,
working since 2002.
it's okay. It's fine. So once you get it to this place, run all. If you run all, you get all the things I've been talking about. So let me quickly go to the medical image because if we are going to stay on this place, we are not going to leave here. From what I'm saying. So I will just go to the medical. That's the second part. So please. So that
Another lecture.
And so please
sorry, please, one last question, please. Yes, please. What I want to say is that I like to ask questions so that I will know how to continue if I really want to go into this. I'm actually excited that at least I have something about machine learning. I always think out of this world. So now from here, okay, all the issue of go to Kaggle, do this, do that, import new notebook, this and that, and you have data like a imported notebook. What is the essence? Like, which stage are we? Is it like a start of analysis or what? I think that can also
Yeah,
help me
just
to know when to continue.
yes, model. That's the first step. You know, you have to know how to hide your data, how to run notebook. Those are just the mini steps. Because if you start teaching you and you don't really know this notebook, this one, but this one that you just learned, if you run all and you're able to understand each part, is going to guide you, because this is the fundamental part, really. That's the fundamental introductory part. It's going to guide you if you have a big data set and you'll be able to work with it, because you could see where we load data, how we loaded our data, how we pre-processed which was not really pre-processing, you know, how we check our data for null value, how we how we train our data, model training, and the rest. Do you understand? So that's just the basic. If you can know this basic, then I'm sure you'll be confident to go and face other data. Even if they are dirty, you can go ahead and look for how to clean it up. Am I making sense?
Okay, thank you. I think at least
okay, so
Hello,
we'll go to the
sorry,
next session,
ma.
please. Because we have just 38 minutes or 39 minutes to go. Yes, it says somebody wants. Do you know something? Can you please add the question? Kindly help me note those questions, please. Because I have to journey it by 12. I'm sorry. Note that question, please. I will answer it. Don't worry. Let me just rush through this one. I'm going to send all those links. So the links are already embedded in this notebook or in the two notebook. So once you click on it, it will take you, but you can use Cargo. Okay, so thank you very much.
Facilitator is very much around for us. If we have more questions, we can ask her. So I would kindly plead our indulgence to allow her run through the next set of presentation, so we can ask her further questions on the group chat. So she's here for us.
Okay, she's on the
Thank you.
Telegram and WhatsApp.
Yes.
Oh, wow. I'm actually sitting on a good mind.
All right, thank you very much. So we going to this next section. So that's image analysis with feature extraction. Okay, so the learning outcome. We have the medical image analysis, image preprocessing, feature extraction, application use cases, and references. Okay, so we're just going to look at it. The other time, you know, we're talking about the tabular types of data. So now we are talking about the medical imaging. In recent case, we have observed the significance of medical images. We know the image modalities. So we have the computed tomography, that's CT, MRI, PET, mammography, ultrasound, and X-ray. You know, these are just detailed about it. You know, in the clinic majority, what we're just saying in essence is that we're trying to cut off the long process. We are trying to speed up cancer diagnosis. Yeah, we are trying to speed up our diagnosis, you know, because most of the time, sometimes, you know, the person on stage 1 at the beginning of the test, and before you know it, the person is already on stage 4 if the diagnosis is not gotten out on time. So what AI is meant for is to speed up diagnosis using the computational method. Okay, so I got this just how we do it, you know, just a step-by-step. Is what's from called from a medium work that I published last year. So you can see this one was melanoma. So we will go there briefly after this. So you can see the pre-processing. Just know that when you say data, first what comes to your mind is pre-process. You pre-process data, you extract the features, you assign labels. That's in supervised cases. Then you set parameters, the fine-tuning, you train the models, and perform the computation. So that's just a summary of if you're carrying out deep learning. Okay, so what is image analysis? Looking at it, what's image analysis? The process of extracting useful information. That's we are taking useful information. So image analysis may locate, you know, may include locating forms, recognizing edges, eliminating noises, you know, like what I just said. Those eliminating noises, those are part of the processing stages, like what I rightly said all the time. You know, texture analysis, you are extracting, you are trying to get meaning from an image. That's what it is in a lame form. Okay, so just Then we said, okay, it's a wide phrase that encompasses variety of techniques, you know, which can fall under subheadings like enhancing images, image segmentation, noise suppression. These are just ways of processing images when we are trying to analyze image for cancer diagnosis. Okay, so this is just an example of image that we process, you know, through AI or through deep learning. So you could see on the left hand side, the image was very dark. So it's just like you are looking at it. This picture, you are looking at it. That okay, assuming they give me a cancer image, you know, if they have a cancer image, it's very dark. What do? You know, you bring in more light by removing the X. So I got this one from MATLAB blocks. Okay, so this is a step involved in data analysis, image analysis, just like I rightly said the other time. You collect the data, you know, you process the data, you perform that modeling, just like I rightly said when I was talking about it in machine learning. So, and you evaluate, train the model, evaluate, then predict your results. Okay, so we have different types of image processing methods. This is just a little one, you know, just by time, this is just introductory aspect, like I rightly said the other time. Okay, so the image resizing, you resize the images because sometimes images can come in a very large format that we might not be able to work with it. So most of the time we resize it, and our default format is 224 by 224. It depends. Sometimes you can reduce it more than that. Depends on your capability and the computational ability. Then you convert it to grayscale. You know, grayscale, most of the time our images, we work with it in grayscale because we've been confirmed that if you work with it in red, green, blue, that's the RGB format, it makes it to be slower. It makes your training model to be slower, and it makes it to it takes lots of computational abilities. So we rather convert to grayscale, that is in black and white format or slightly gray and white format. So segmentation is that you are just extracting, you are making the features to be more pronounced. You know, you look at it, okay, because if you are looking at it, if the data set comes in from, by the time we get there on it, I'll show you how we segmented the images. Then augmentation, you're increasing the images most of the time when the image size is very small. When you're working with small image size, you see, because when you're working with all this data, you have to have large image sizes. So we augment, that is, you're increasing the augmentation. Most augmentation means you're cutting, maybe if it's in, maybe the image come in left form, you get a right form, you get a the upside down, you know, and add all those image patches and add it to your data so that you have more data set. That's just augmentation. Then filtering, you filter the images depending. Sometimes you work with gray filters, you work with GSM, that's GSM grill, something GSM, we just call it GSM, that's the short form. Gray comatrice, something, you know, it just is a mathematical function to extract the images. You are extracting images from the overall image. So that's what it is. Then radiomics, you work with omics. You know, you extract the omics image. Those are images that come with those when we're working with is it tissue stained images, because that's how you can get images with omics. So when you see all those images, when they come, know that, oh, it's radiomics you're going to do, just don't bother yourself. Okay, bounding box. Bounding box is just a form of you have a box, you know, to just expatiate. You are putting more light to a form, to a what's it called, a section, a part. That's what bounding box. And the libraries we use the TensorFlow, we use the Keras, we use the Python, PyTorch, and we have the OpenCV. Here I'm talking about deep learning, strictly deep learning. Okay, thank you very much. So feature extraction. So feature engineering is just the combination of feature extraction, just like I rightly said the other time. You are saying, okay, these are the images you are focused, and how do you get your feature extraction? Before we can do any image analysis, you have to read about the data, like the melanoma. Oh, we know that what normally noticeable, you know that the images come, you see the what's called, there's a slight difference between the image of melanoma compared to normal images. So that's where you get your feature extraction. So you look at that exact features. What are the features we are looking at? So there are some features that are really, really peculiar to different types of cancer. Feature that's features peculiar to them. So, and that's when we now do the feature selection, because when you have loads of data, like data I worked with, or I've been working with for some time now, is that 1,250 symptoms, you know. But looking at the case control, we had the case control, we had the features, we have the what's it called, the symptoms and everything. How are you going to work with that? That's where feature selection. So we have something we call feature important. That is, you're selecting the top features. You can select the top 50 features, you can select the top 20 features, you can select the top 100 features. But most of the time, we work with top 50 features. And when you see that the top 50 features is not giving us what we want, then streamline it to top 20 features. So that's feature selection. So it will tell you what actually you needed on that data set when you're giving large data sets. So I'm not going to go into details of this because it's going to. So training images now. So we have different types of images. Artificial neural network. You just you know, we have the input, we have the output, we have the model in our middle. So this one is just sometimes trained from the back, trained from the front. You know, this one they are just giving us wider view of types of neural networking. Okay, application can be used for all, we can use it for all manners of things, you know, for computer-aided detection, for computer-aided diagnosis, for results, for diagnosis, for prediction, you can use it for drugs too, for drugs, you know, selecting, okay, that one would be machine learning, supervised learning. You can use it for not only machine learning, you can use it for deep learning too. Because if you see improvement in an image compared to the one that has not been improved, you know, there's so many use cases that you can use deep learning for. And this one just shows the differences between machine learning and deep learning. The machine learning, you can actually see your features. You can see features extraction. You can see, okay, these are the features I'm extracting. But deep learning is combining together. If you combine the feature extraction and classification together, to whether tell you whether the input is this or that. They got the image from analytics with here. There's another blog post that is free. Yeah, some are not free, but at least to a level, to an extent. The introductory aspect is free, so you can go into analytics video to get more on it. So I will just quickly go to the Medium post and the notebook. So, okay. Sorry, I'm rushing us because we don't have that time. So this is the notebook. This is a work I did 2021 for melanoma with convolutional neural networking. So I'll just I can just send the detail. Let me just send it for you guys. If you just want to follow me, I will make the explanatory transfer so that we have an idea of what we are working with, so that you don't get confused. Sorry. Yeah. Okay, so like I already said, so what we're doing, the use cases we plan to do or to check is the melanoma diagnosis. Melanoma is a form of skin cancer. That is a malignant one, you know, the one that says, just a form of skin cancer that develop from pigment producing cells, you know, called melanocytes. Okay. So you can see the task as and so this notebook is written to identify melanoma in lesion images in the target data. So this data set, I use data sets on cargo soon, you know, so that's the ESIC. So it's taking us to the ESIC cargo data set. So this is the ESIC cargo data set. If you want to read more about data, you can read more. You can see it. It's going to give you overview of everything you want to do. You know, that's beautiful thing about cargo. Yeah. So yeah, like I already said the other time, you import the necessary library. Sorry, let me just go to the notebook so that we are reading it as we're doing it. Sorry for that. So, no. So I'm rushing you guys. I'm sorry for that. So sorry. Yeah. Okay, so this is the notebook now. If you want to run the notebook, you just click on edit. It's just going to give you the details. You know, it's just edit and you're there. So you can see that he has already added the image data set that I use. This is a large data set, so I use GPU. That's one beautiful thing about using Kaggle. At least it can give you little GPU, you can give you GPU of 30 hours to train your data, you know. Then, but if it's Colab, before you know it, I think few hours will tell you that you've run out of GPU. Sometimes it might not even be up to an hour, depending on the image sizes. So this is the image classification. So you could see the type of content, you know, you enjoy this, you know, it was a notebook that I did for a project. So yeah. So the most common form of cancer, you can read it. I can download and read it and send it all over so that I don't go to details on it. So you import the necessary libraries. Now, and I told you that we use Keras, you can use Keras, you can use TensorFlow, you can use PyTorch, you can use any form of image deep learning method. So now we're using Keras. I use Keras and TensorFlow, mix it together. So you add all the necessary libraries, you know, libraries. So these are the libraries that we use, you know, just for, then this one is for splitting the images. When you see train test splits, you know, I explained the other time that there are sets, there are data that training data set, test data set, that is the one that I used to train the model, the one that I now use to test it after, or that doesn't have the labels. Okay, so this is it. So you have the sequential, this one that just all the details. I think this ones, if you want to go into them, then you have to read them, because there's some that's still black box that it might not really, you cannot really say, oh, this is how it works, or this is how it works. But at least you know the detail of the sequential, you know, that is taking the images one after the other. So you can just read this one. This one is for image analysis. That's a pillow. This is the operating system. The whole S is the operating system. NumPy is to calculate the mathematical function. The matplotlib is for visualization, like I rightly said all the time. So this one now is just to, this for folder, you know, just to analyze folders, what's it called, arrangements here, you know, that's, so about that, so this story about all the data sets. So we load the data set, so you can see the data set that we loaded, so the base parts, you know. This is very easy once you already have your data set, you know, that's if you're using Kaggle. But sometimes most of the image, when you get to the professional and the expert level, there is a new image entirely. So for this one is introductory, that's what, like I rightly said all the time. Okay, so I think I have one that I've run it because it's gonna take our time in running this, yeah, because now we are talking about image analysis. Yeah, let me see whether I've run. Okay, I see there. Okay, I'm there. Continue editing. Thank you. Let me see whether I have. Oh, Lord. Sorry, that's taking my output away, so I have to rerun it again. Okay, while waiting for that, so I can just run that, run all. So while waiting for that, we can just move so that we can just see the view of all the details on Medium, because I put it in. Okay, so this is Medium. So this is data set now. So we split the data, so you can see what I used to split the data set now. Now we are using 80%, so you can see the data directory, the validation split. Sometimes the validation split, we use it as test split soon, you know, because most of the time, sometimes we split it, okay, 0.8 for the test for training the data, that's 80%, validation 0.1, test 0.1, but here we just use 0.2. But I think it's really affected. I think I did an enhanced one. So you could see it now. So we viewed our images. So I told you that this one is for viewed images, just for you to see how it is. So these images that we view. So you could see this data set consists of 9 basic types of cancer diseases. So we have the vascular lesion, nevus, pigmented, and all manners of melanoma or melanocytes. So you could see it here now. See the melanoma, where we are going to use melanoma. So now we have 9 data sets. So sometimes we have other form of what's it called? Yes, others are melanocytes, but we are going to, our target is melanoma. So kindly take note of that. So we we auto-tune, so we tune the data, so you can see we tune it, you know. Auto-tune is just for you to prepare. You prefer the images. Are you going to prefer it line by line? Are you going to prefer it sequentially? And then it's just like you preparing the environment that you want to use it to work. Okay, the normalization is sometimes the data can come, the images can come big, some can come in large pixel, while some come in small pixels. So you have to normalize it and make it something like you are dividing it and getting the what's it called, reaching a midpoint. That's normalization. Okay, so you could see I put into common statistical distribution sizes, because when you're talking about image analysis, you're talking about mathematical computation. You have to have the mathematical computation. Okay, so that's it. So we normalize the images, you know. After normalizing the images, so I just put this one just for this. So you can see the norm classes now is 9. Okay, you could see that we do not explicitly say, okay, this is features, this is feature we are selecting, this is not features we are selecting. Just like I rightly said, the difference between machine learning and deep learning. So you could see, so we select our norm classes, you know, this adjusted. So you could see that model, you know, this is the model, this, all these things, they might be black box to you, except you get to a level. So that's the truth. If you try to want to know more about this, then you get it. But if you now say, okay, you want to put, okay, I'm seeing it, it's looking in black and white. No, just know that they are black box model, black box now. You know, if I start getting into detail, this is just a 2-dimension. This shows we are working with 2-dimension. This is scaling aspect. You know, I was talking about normalization. Just to explain that this input layer, you know, just to this one, max pooling sometimes is to extract noises, you know, flatten the images, the dense, you know, these are just you are trying to hyperparameter train, you know, try to tune your model. Okay, so now, so you could see our model now. So you could see we trained with 180, that's 180 by 180 images. You could see the images we came out with. So this is accuracy now. So visualizing the model accuracy. So this accuracy, you could see that this accuracy was not that much. It wasn't that very good, you know. I intentionally use this. So it wasn't that very good. That was when I just started training images, you know, learning how to train images there in 2021. So it wasn't that good. So when you see images like this, it won't be accepted, because you could see that the training accuracy is crazy. It was just 0.6. Where the red, what's it called, the orange and the blue meat, that's where the training accuracy landed. So it wasn't so good. So, but at least just like you started. So you now want to boost the performance. When you see that, because what I noticed then, there was that the images were not enough. So what did? I try and augment the images. That is, add more images to the data that I was using. And another ways of boosting is that you use the layers of the network. You know, there you see this part that I was talking about, the layers. You know, we are talking about 9 types of data here, or 9 use cases here, and we're just talking about one. So this normally sometimes occurs when you're training your images. Then you add dropouts and tune it straight. Sometimes tune it straight, you know, L2 normalization, freeze the numbers of neurons. So those are ways of boosting the performance of your images, because like I already said the other time, that they don't joke it, that when you're talking about medical, you are programmed with AI, then it has to be, well, then it has to be between what's it called, 0.9 or 0.6 to 1.0. Yeah. Okay. Sorry, I think I have to change location. Isn't my what is excuse me, please. I have to change location. I'll put it in the other class. Sorry, please. Sorry, please. I just have to change location. Okay. Like I was saying, so we augment the images, considering the small data set. So that is adding more to the images that we have. Okay. So when we added to the images, to see what we have, so our training improved. You could see that there was a bit improvement. So now we have the 0.65 0.65. Sorry, I'm working to my next to my study meeting I'm attending. Sorry for that. So I hope you guys are hearing me. So let me just stay somewhere here. So the training images, so there was improvements now because of the modeling, because of the augmented images. So you can see the model performance looks good and it ranges between 60 to 65 before I now worked on it newly again. So this is what we're able to achieve. So you can see training medical images can be an obvious task if the image size is small and can cause overfitting, but can be fixed by augmenting the available images that we have. Okay, so that is that. So let's see whether our images have, this has finished running. Sorry. Oh, we're unable to save it because it has been modified in another location. Thank you. Okay, just want to say. So because I ran it in different places, so it's not saving it for me. So I think this kind of thing, I think they have to start off, but yeah. So sure, so this is what we got. I think I'd have to run it all over again. It was because I opened it in multiple locations, you know, it's an sure. Okay, no. Oh, sorry, this is another data. Sorry for that. Let me run it again. Am I audible? Since I'm talking to myself. Yeah.
Yes, we can hear
Oh,
you.
you're very audible.
Okay,
We
thank
can
you very
hear
okay, thank you very much.
you.
Okay, so
Thank you.
I think I will have to restart, but while restarting, so I will just go to the one that we now enhance, the enhanced one. Let me just quickly just open that. I think I have a few minutes to go. Yeah, don't worry, like Ashra said, I will. Okay, so they're calling me to come into another place. Okay. Sorry. I'm moving everywhere. I'm in the office. So sorry about that. Yeah. Okay. Thank you, Auntie. Good morning. How are you doing? Shoot. All right, thanks. So sorry about that. I'm moving location. Okay, thank you. Thank you, Auntie. All right. All right. No, commit plug. I think. Oh, wow, okay. No problem. Thank you. Okay, so that's on that melanoma. So I don't know whether it eventually run. Let me quickly check whether it's run. And yeah, trying to. We're still running. Okay, so I think let me just use that one. Let me just I know changing location. Kaggle always have issue with that, you know. Yeah, I'm on the internet. Just that's one thing. When you're running medical images, your internet just has to be stable. That's the truth. Internet has to be stable. You have to have sometimes use Wi-Fi. Like if I'm at home, I use the Wi-Fi. You know, just have to be stable. That's it. See, it's just giving me issues. Pages unresponsive. It's because of the movement. You know, moving from that one place to another. Okay, so what do I want to? I said let's go. Let's check the other one. Let's see whether we can just check the second medium while waiting for that, because it looks as if it's taking much of our time. Sorry, I'm trying to run up because oh, I keep clicking notebook. Sorry. Shoot. Sorry, the attention is divided. Yeah. Okay. 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 So I will just go to the second one that why that one is running. So let's hope it is able to run before we end the class. So sometimes when you're training your models, sometimes you just leave it and let it be go. Sometimes you sleep and wake up. But when you're sleeping and wake up, there's a way we do it. We make sure we'll make sure the model picks the best accuracy. So once it picks the best accuracy, we are fine. So we just wake up and meet our model. We have a way of dockerizing our model the best. So once we pick the best model, we dockerize it. And so when we wake up, we see the output, we see it on it, So it's always that's one beautiful thing about learning how to program. So we can always maneuver our ways. Yeah. So I just want to show
I
the
think
video. Yeah.
to ease you into the whole training so that we won't inconvenience you any further. I've seen two people raising their hands. I think you can respond to their questions, and then we can the other details we can have it more discussed on the group, sort of.
Okay.
So I think I've seen Dr. Patricia Neji and Miss Idayatullah.
Okay.
Yeah. So, Doctor, you have the floor.
Good morning, ma'am, from here.
Good day.
Yeah, when you mentioned in the beginning, you mentioned something about accuracy in the data, like when analyzing your data, and you mentioned that the accuracy should be on between 0.9 and 1.0. But the data you showed us, yours was 0.65. Does it mean that it was not accurate or?
Yes, it's not.
It's not accurate. Okay.
Yes.
Okay.
I
So
told
that
you that
means
it was
you
when
have
I
to
just started.
rerun it again.
Not rerun. You have to improve the accuracy. That is,
okay, improve.
I made mention of some things. Number one, when you don't have enough data, you could see that I was having issue with data. I think that it was just because the data, I went to cut it. I divided, I cut. We have the data was, I've forgotten the exact size, but it was like 13 point or 11.2 gig. So I looked at it, how can I run 11.2 gig? So I selected some parts. I think I selected maybe 200 and something for that, So, and that was what affected my result. So what I now did is that I now cut the slices. I did augmentation. That is, we are cutting from that part of that data. You now try and make patches, more patches from it, and now add it to the former data you have. Those data, you've already reduced it. You've already reduced the data. So excuse me, if your background is noisy, kindly mute yourself, please. Okay, thank you. So if you like, if you're taking the data, I took a data now, you've already resized it. What do? You now augment it that is, you have more sizes, right? More images, right? You now add it to the data you have. Do you understand? Then it will work. Then another thing is that you fine tune it. That all these ones that I'm talking about is fine tuning. Another thing is noise. You remove noises from it. Noises that all those parts, when you're looking at images, you see some that they're not part of the images. Maybe when the radiographer is taking the images, maybe it's something there's just a scratch on it. Those are noises for training data set. So you have to remove. What do? You segment. That is, you have to remove the exact patch. That exact, when you're talking about the melanoma, sorry, let me just show you the picture now. See that patch. Can you see this patch? Like, okay, if I want to see this line now, if you see the line of this, my screen now, that line is an image, is an example of image. Do you know that? Right? Am I audible?
Yes, I can hear you.
Okay, thank you. So this
I
line
guess you have to zoom out so that you can see the line different from the melanoma.
No, I can't zoom out. I'm taking it from, what's it called? I'm taking it from medium. I think that's the, okay, from here. Okay, let me increase that. Sorry. Short. Okay, Look at this now. So you could see the line is from, so I can't zoom more than that. So you could see the line now. Can you see the line on that? This my melanoma image that I used
Yes,
there.
I can. Yeah.
That's an example of noise. So what you can now do is that you now take that, you extract this feature, just this reddish, that's the lesion that we have in here. That's the lesion on that skin. So you extract this lesion, and that's now the one that you now pass into your feed or into the model. So that one will produce more results, higher accuracy than ever. So there's so many methods. So this is a updated one that enhanced. I call it enhanced one. So that I had to use, to produce, because actually when I submitted, said no, they're looking at the accuracy. Yeah, they uploaded my work, but looking at the accuracy, no, it's kind of work. So I intentionally published that so that others could, at least people that are having low accuracy, can improve ways they can improve on their models. So I now publish the enhanced one here. Although it was on Medium before, the owner now told me that he's trying to expand his blog. So now carry from Medium to this place. Yeah. So this is it. So you could see, if you see the accuracy of this one now, this one is higher. I can't remember, but I think it's 0.9 or something. Yeah, because I've added all those details in it. So this one, you have to be, can you see now? Can you see the accuracy here now? So it was 0.9, 0.93, yeah, 0.93, yeah, between 0.93 and 1.0. So that's it. So there are ways you enhance. Once you see that you are getting low accuracy, know that something is wrong with your image. That's fine tuning. So you look at those details. If you read that Medium, you see all those things that I highlighted for enhancing accuracy. Thank you.
Thank you, ma'am.
You're welcome. Any
I
other
think
question?
we can hold on to the questions. Any other questions can be asked with the group. So
Okay, somebody just
allow.
mentioned.
Okay.
Okay, I
Because
think that's it. Okay. It's just on that. Yeah, that's what I just explained. So, Patricia, you're okay now, right? Yeah.
all right.
Am I not the only one here and not seven? Okay,
Yes,
that's
yes,
10.
yes.
Okay, so
Thank
that's
you
that.
so
So
much.
thank you very much, everyone, for having me.
Yeah, it's indeed a pleasure, and we okay. Let me first of all appreciate you taking out your time out of your tight schedule. So we had to look for ways. We want to enjoy her, so that was why we made sure that she's there with us. But she had a very tight schedule. But despite that fact, she committed her time to be here with us today. So really appreciate her efforts and the invaluable knowledge she passed to us today. So not everybody has interest in machine learning, but today's class has in fact inspired a lot of us. I also am inspired to start working on machine learning, and especially the data science part that she mentioned along the presentation. So, which is very, very integral. If just like I made mention of that fact while we were doing the career um, discussion and prospect and scholarship, I made mention of the fact that if you are a bioinformatician and you are not taking data science seriously, so it's as if you are shooting yourself in the leg regarding the opportunities and the wealth, the financial gratification that comes with that knowledge. And it's not that difficult. So if you subject yourself to 3 months intensive training, trust me, you'll come out becoming an expert in that. So and it's you can there are many free resources online that you can apply for, and there are also paid resources on Coursera that you can and Kaggle that you can go on for. There are other ones on Allison too. Allison is another online platform that offers courses like data science. So we also intend to do that in Noblekinmat, but because there are many resources available online already and that are easily accessible, so we wouldn't want to stress ourselves doing such. So and as such, we really appreciate the introduction that we had today. So I know subsequent classes we are still going to have more discussions with machine learning. So we want to thank Mrs. Mary, sorry, she'll say I should call her Mary Adeomi, for taking out the time, and I really sincerely appreciate the effort. So I'm blessed by that knowledge, and I'm very sure that many people would have questions, and it will be addressed on the group, hopefully. So that is that part about appreciation to our lecturer. So secondly, I want to sincerely appreciate.
Thank you. I'm taking a bow. Thank you very much. Thanks for having me. Bye.
It's a pleasure. So I want to sincerely appreciate the participants right from day one for being consistent and amazing. So if I should start mentioning the popular names here, so I know everybody will know their names already. So and everyone for being here. It's not easy boarding data and also electricity and being making your time available. Apart from the fact that you are committing your time for this self-development and impact making for yourself, it's also an avenue that we are also proud to bring, get like minds coming together. I can say for a fact that the first contact I had with Mrs. Mary, was in our last cohort. So I mentioned the fact that in the beginning of this session that we are here. I'm also here to learn, and this is also a platform to meet new people. So this is why I'm also encouraging everyone that, despite the fact that you're an expert or a beginner, attending programs like this will not just increase us in our knowledge, but also increase our collaboration and network. So this is one of the goals. So thank you so much for being a part. I really appreciate and sincerely on behalf of the Noblekinmat entirely. So I want to appreciate us for being here. So and then lastly, the sent some the message regarding accessing the certificate for attending this 7-day course. So I think it's counterproductive if after spending much time and there is nothing like tangible to show that, oh, this is what I mean, like a certificate or a guarantee to show that, oh, I really truly attended this. So that's the function of the certificate, and the process to obtain that is already sent to us. Some have already messaged me regarding not having the capacity to pay now till at the end of the month. So we are still um, looking out for that. But for those that are paid before the end of the week, the certificates will be sent to their emails. So thank you so much, and I really appreciate your effort. So I will take one or two comments from the audience on anything you think we can improve on in subsequent classes or in subsequent sessions. So or questions regarding what we've done so far.
Thank you very much for
I
this wonderful
really appreciate you
opportunity.
for this wonderful opportunity that you have given us to learn more. Honestly, there are some things I'm hearing here for the first time, and to me, it has been an eye-opening encounter. Thank you so much for bringing the resource persons, and the resource persons have really opened our eye. In this, for a lot of us in Nigeria, you think you are doing well until you hear what is happening outside. You now know that you are so many years behind, so many years behind. So thank you so much for opening us up to some newer things that are happening in the world, and we are spurred up to learn. Really appreciate you. Thank you so much. God bless you so much.
All right, thank
Thank
you
you
very
so much,
much
sir.
for this. All right, thank you so much for this wonderful opportunity. In short, if I don't speak, then I'll see myself I've not been grateful. Honestly, this 1 week has really transformed me. It has changed me. And I know that some of the courses we are doing that introduction. What if one wants to continue with a particular one, especially this machine learning? I'm really interested. And I must say, you have really opened our eyes. It has been insightful. Like me, I had a very little knowledge of bioinformatics, but when I joined this seminar, oh my God, I feel like sleeping with my laptop every time, exploring. It has been very rewarding, and God will bless you for enlightening us this far in Jesus' name. Amen.
Thank you so much. I'm still expecting my bottle of Coke.
Mr. Kintola, I just want to say thank you.
Okay.
Thank you very
Go
much.
ahead.
Thank you very much, Dr. Ashraf. Everything you've taught us here is so wonderful. You've really opened my mind and my eyes, and a lot of things have come into this mind and machine learning on bioinformatics.
I'm really impressed. I just want to say
thank you very
you.
much.
Though I have 8 months to share, but maybe the 8 months is kind of fully packaged.
Dr. Patricia. Hello. I think Dr. Inlet is speaking. Maybe after her.
Okay. Yes, I wanted to appreciate you for this in fact, having the mind to give to people, as in to give your knowledge to people, especially to us in Nigeria. I'm a vet, and I've really thought so much about going into bioinformatics, discuss my friends abroad and all that, and this training was just what I needed at this time to move me to the next level. Thank you very, very much for giving out to us. God will reward you and bless you. Thank you very much. I've learned so much. In fact, I'm going back to relearn all I've learned from this training. I'm going back to learn from day one. Thank you for uploading the videos, the lessons for each day. So I'm going back to learn all again afresh, so that I'll be abreast with everything, and I think from there I will scale up. Thank you very, very much. Thank you.
You're welcome. All the videos I would upload them tonight, hopefully. Then I will wait for the ensemble. So I'll upload that.
Thank you very, very much. You've done massively well. Thank you, sir.
One more thing. I remember we still have something on molecular docking. I don't know if you can also forward it too. Very important, molecular docking.
Yeah, he promised to send it as soon as possible, so I'm expecting his recording. So I will also upload that alongside other recordings.
Okay, please also try to give him a reminder, sir, and extend our greetings to him.
Okay, sir.
Okay, I just want to say thank you. Don't mind me. I was waiting for that to finish. Like you've really been like so helpful, impactful, and everything. Like I'm super proud of myself. Was it last week? I have an interview with a potential supervisor. I tried to apply for bioinformatics and was like, okay, what can you do in bioinformatics? I was like, I know how to class, I know how to align, sequence alignment. I was like, okay, let me give you a trial. And I did very well. I'm just so happy, like
wow.
Of the family. Like I just waiting for the testimony of the full funded scholarship. So I'm just waiting for it. But I'm just so happy. Wow. Thank you very much.
We are rooting for you. We are rooting for you. You'll clinch that title soon.
Thank you.
Thank you so much, Doctor. Thank you so much. Go ahead, Miss Yedule, or Dr. Yedule.
Miss Yetunde, in fact, undergraduate student. It's been awesome attending the training. I learned a lot. In fact, thank you. We really appreciate your efforts. Though I joined the Cohort 3, and in fact, I learned more now because then I don't have a system, but at least I was able to do some practice and still looking forward to attend more of the training so I become a professional in it. Thank you. And it was good having, being in the midst of colleagues that are above me. It's interesting. Really appreciate. Thank you.
You're welcome. I think Mr. Ozubechi.
Yeah. Dr. Ashraf, thank you very much for the section, organizing the section. Very informative, especially as undergraduates that have been looking for our way and trying to understand things. This was very clarifying. I'm really grateful. And I want to be part of the group chat, but I don't know how to join. I don't know if I've not seen the link or something.
The WhatsApp group has been filled already up already, so I'll create a new one and then I'll send the link to the Telegram page.
All right, thank you very much. I really appreciate.
You're welcome.
From what I can see, I notice this is like cohort 5. What about cohort 1, 2, and 3, 4? Can one have access to it?
Yes. We do not have a comprehensive record of like the recordings for cohort 1 and cohort 2, but we have that of cohort 3, and we actually shared the link, I think on the first day or the second day, to the Telegram page, and it has already been pinned. Some of us have already pinned the message. You can check the group, so the whole view of this whole days, and it's already there.
Okay. Or please, is it possible to resend it so that we can access it easily now? Because I'm just hearing this.
Yes. I will share.
All right. Thank you, sir. Thank you, sir.
You're welcome. I think Miss Dr. Mary Sule raised her hand, and Mr. K. Diallo and Mr. Muhammad Adeomi. I think the Dr. Mary Sule, and then followed by Dr. Muhammad and Dr. Ken Diallo. Dr. Mary. Maybe Dr. Muhammad.
All right. Thank you very much, Dr. Ashraf.
Yes, sir.
Although I joined today's class late because I had some other presentations I had to run to. Though when I joined in, I couldn't really follow today's class as such, but the ending part I actually, when I joined in, it was enlightening and enriching from the presenter. I just want to say that I really appreciate you and the whole team for this wonderful presentation, putting us in top gear and inspiring us to acquire inspiring our test for knowledge into what is now operational in the world, in the global setting. May Allah continue to enrich each and every one of us in this program. And I just want to say a warm thank you once again. Thank you very much.
You're welcome, sir. Thank you so much for the prayers. And we got elevate us to higher rank. Thank you so much. Is Dr. Sule here? Dr. Mary Sule. Okay, maybe Dr. Kelly allowed it. Okay. I think if there are no more.
Hello.
Okay. Hello. We can hear you.
Okay. It's Mary Sule, Miss Mary Sule.
Okay.
Just want to appreciate the resource persons from day one to the end of this program. And I'm standing in for all of us from Confluence University of Science and Technology, Kogi State. We've really learned a lot, and we are grateful. Thank you.
Oh, thank you. Thank you so much, ma.
Please, I want to find out
so much,
if someone wants to develop him or herself on a particular course, because I know these are introductory. How can we go ahead about that, sir?
Actually, we have a course on genomics 2 that we actually had that I think a couple of weeks back, but it's still on. If you want to continue on genomics, we had a course for that, and it involves doing more analysis, submitting to NCBI, analyzing your data, raw data, and some other features. But after the session, we are going to come up with another in-depth course on each and every specialization that was discussed that was taken in this fourth cohort. For example, we've been working on improving or coming up with a course on microbial analysis, some other analysis regarding proteomics. So we are taking it one after the other because most of our facilitators are very, very busy. So, but before the end of the month, we would come up with the schedule and we would let you know about the plan.
So thank you so much.
You're welcome.
I don't know what I can say. I actually signified.
Yes. Yes.
Okay, thank you very much, sir. I really appreciate. I've actually been on the bioinformatics group on WhatsApp. In fact, that was a particular time I actually contacted you for a scholarship to even kind of learn because it required me to pay a particular amount. But when I actually saw this and it was free access, even though on the Google form we had to fill okay the amount for the certificate. But because I had wanted to learn, you understand, I felt okay, the certificate is something I can actually look at later. I really want to appreciate you because I wanted to leave the group, but I felt no, I want to learn bioinformatics and being in the group of people, that actually do things like this will be very good, even though I've not really attended any of the webinar, but I never regretted attending this one. In fact, there was a time you posted a particular content on DNA methylation, about cancer, and I was so thrilled. It was short, it was not long. So lazy me, I was able to go through it. I saw some genes on cancer. I read them. I said, oh, I think I understand more. Just with that little content about how some things, those proteins that cause some things affect people with cancerous cells. And then by the time I did one Coursera course and then I looked at methylation, I was able to share it. I was confident to share it because at least with what I read on the group, with what I learned on the Coursera, I think there was a correlation. That means the information is the same, not that I'm cramming now. I think I have more understanding. So thank you for bringing the resource person. Actually, the person that came today, it was so obvious that she was busy, but she was passionate about what she does, even though she was distracted, but she was still able to at least give her some time. So some of these people are not easy to come by. You can't. But I hope that we'll be more available at least to an extent to guide us to learn some things. For me, I'm still at the crossroad of how some of these things are linking to animal production or agriculture at the whole. But I know that at one point in time, I'll have to pick a niche to be able to understand better. Thank you very much. And please, sometimes we'll disturb you on some things. Please just know that we are still kind of learning, and that's why we have some of those excesses. Thank you very much. And to all my colleagues, really made this thing very, very interesting. Mr. Effiong, and many people have
Thank you.
contributed room of mine. Thank you very much. God bless you all.
Thank you so much. I really appreciate you once again. We can appreciate you totally. How do they say that in English? But notwithstanding, our profound gratitude is can't be totally expressed by the words of our mouth. So we want to thank you once again. So I would not want us to deliberate further to save ourselves some data, so we can take our discussion to our family meeting on the group. So we can continue on our family group. So thank you so much. I want to appreciate you once again. So may God continue to bless every one of us. So and by the next cohort training, our goal and aspiration is that those of us that also attended this session, so that from us will be among those who would also participate in training the next cohort, because that was practically what's happened in this particular training. It was some of the attendants in the last training that were the trainers of this particular cohort. So, and that is
Wow.
what we intend to achieve. Yes. So, except Dr. Abdul Qadir, all the other trainers, they were attendees of the last training. Except Dr. Abdul Qadir and Mr. Abdullah, all the other trainers were the attendees. So even our presenter for today, she also joined just for the sake of informatics and learning and some other stuff. And we got to form the collaboration and we formed the research group. And from the research group, we discovered that people even have more stuff than what they came to learn. So that was how we formed the family, and that was how we have it here. So I'm looking forward to meeting every one of us in the next course. Come and also train other people in the aspect of bioinformatics that they are yet to know. So that is our goal. So that is our aim, and that is what we intend to achieve. That is what we set out to achieve. So we pray that God will grant us that He will grant us that the answer to that prayer. Thank you so
Amen.
much, and I really appreciate that. Someone wants to say something? I think I heard a voice.
No, I was just saying amen to your prayers.
Oh, okay. Thank you so
Yes.
much. So see you on the group for more details and for more explanation and for more information. Thank you so much, and have a nice day.
Thank you.
And you, Faith, thank you so much, sir.
Thank you so much for giving back to us. Thank you.
You're welcome.
Have you bought it? Have you prepared it?